Hello, everybody! Welcome back to Easy Learn, and today's topic is trigonometric functions, and we're going to be solving some more questions today. If you haven't watched my trigonometric functions explanation video yet, pause right here, check the link in the description below, try to understand the concept, and then come back for solving. So today's question is a ladder is placed against a wall. To be safe, it must be inclined at an angle of 70 and 80 degrees to the ground. Now let's suppose this is my ground and it should be at 1.5 meters. And let's say if this is my wall and it's 5.8 meters, and this is a ladder that is resting on the wall and attached with the ground. Now the question is the ladder safe? And part B says, calculate the length of the ladder. Now, how do I figure out if the ladder is safe? In order for the ladder to be safe, we can see that it says it should be inclined at 70 to 80 degrees to the ground. Now, if you notice, this specific situation or this drawing represents a right angle triangle. The wall and the ground is making a right angle triangle, and the ladder is making a specific angle that we don't know. So before we jump on to solving this directly, we could just grab out a right angle triangle out of this, and we know that the ground, the base is 1.5 meters and the wall is 5.8, and the wall and the ground is making a 90-degree angle right here, and the angle that we're supposed to be finding is this one, the one the ladder is making with the ground. Now once we have all this information set, we need to know that what are we exactly going to use. The fact that we're dealing with trigonometric functions is because we are dealing with right angled triangles, and trigonometric functions are used to find lengths or angles of a right angled triangle. And when we talk about trigonometric functions, you should be well versed with the sine cos tan table, and the sine cos tan table represents something like OAH. So you should be knowing what is OAH. So A and H is something like this. A is the adjacent, that is the length that is enclosed between the 90-degree and the angle. O is the length that is opposite to a given angle, and H is the length that is right opposite to the 90 degrees or the diagonal length. And how to implement sine cos tan is that you write sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Now in this particular example, we can see that there is a length that is enclosed between 90-degree and the angle, although the angle is unknown, but that's not important. The important part is that there is this length available to us, which is the A, the adjacent, and the other length that is just right opposite to the angle, that's our opposite, the O, 5.8 meters, which means that we are dealing with the adjacent and the opposite, so we can just get rid of the hypotenuse length. We don't have to really talk about it. So we have our A and our O, so we can refer to the table. A and O together come under tan, which means we're dealing with adjacent and opposite, so we're going to be taking tan theta equals opposite over adjacent. Now moving on to solving this question. So tan theta equals opposite over adjacent. I can just replace my theta, my opposite, and my adjacent. My theta, I can just take it as x, and I can take my opposite as 5.8. So tan x equals 5.8 divided by 1.5. Now tan theta, when it goes to the other side, we already discussed in previous videos what happens to tan when it goes to the other side, so you can just refer to those videos for a detailed explanation. But for now, we need to know that when tan goes to the other side, it turns into something like this, tan minus 1, and tan minus 1 refers to tan inverse. So x equals tan inverse of 5.8 divided by 1.5. Now, coming on this specific point, you need your scientific calculator. If you have one, well and good. If you don't have one, just go on Google, type scientific calculator, and you will get a pop up that shows something like this. make sure your calculator is set on degrees, and then you have to find the inverse. So you have to click the I and V that you see there, and then you will see after clicking I and V you have sine minus 1, cos minus 1, and tan minus 1. So I'll be taking my tan minus 1, that is the tan inverse, and you will have something like this that you can see on the screen. Arc tan 5.8 divided by 1.5, and that is equal to 75.4998, and so on. So I can just round that off and write it as x equals 75.5 degrees, which means that the ladder is making an angle of 75.5 degrees with the ground. So coming back to the question, is the ladder safe? Yes, it is safe because it is making an angle that is between 70 to 80 degrees. That's 75.5 degrees. Moving on to part B of the question that says calculate the length of the ladder. Now here you can see that we already have the length of the ground, we have the length of the wall, but we don't have this specific length, which is the length of the ladder. And if you notice, it is the length that is right opposite to the 90 degrees. That means it is the hypotenuse. But the best part is I do not have to deal with sine cos tan anymore because I have two lengths already available to me. I have my adjacent, I have my opposite. Now, when you have two lengths available in a right angle triangle and one is missing, you use the Pythagoras theorem. And the Pythagoras theorem is a squared plus o squared equals h squared. Now, here we have our a and our o, only the h is missing. So you can just use this formula and find out what your h is. So I'm going to be replacing my variables with the numbers. So a is 1.5 and o is 5.8. So 1.5 squared plus 5.8 squared equals h squared. Now if I take this h squared, if I take the square to the other side, it turns into a square root. So I'll be writing square root of 1.5 squared plus 5.8 squared equals the h. And h is basically the length of the ladder. So writing all of that down on my calculator again, so square root of 1.5 squared plus 5.8 squared gives me something like this. That's 5.9908, and so on. So I can just round it off and write it down as h equals 5.99 meters. That means that the length of my ladder is equal to 5.99 meters. That's pretty much it. Hope you enjoyed the video, and do not forget to like, share, and subscribe Easy Learn. If you have any questions, any queries, any confusions, just drop them down in the comment section below. Hope to see you in the next video. Thank you so much for watching.